Does everybody have a piece of paper? Made a big circle with a compass. Right? Okay, now we're first going to draw a radius. Everybody should know what a radius is. What's a radius? So you should have a hole in your paper. Mark that hole as your center, right? So make a little dot so yours looks like mine. Everybody's looks like mine right now. Okay, so now we are going to draw a. I guess I should give you some straight edges. I can do that too. So yours should look like mine right now. Is yours looking like mine? All I'm asking you to do is draw a circle. Okay, now we're going to draw a radius. You should have a straight edge, and it's from the center to the edge. Now, my thingy, I don't write very well with this pen on this. They don't have a texting tool either. Oop. But I'm going to try my best. Yours will probably be neater. So this is what's this called? Radius. I don't know why. This one does not write very well. It has to do with this software, I think. Radius. Okay? Yours should look a little neater. I wish it had a text that I could type, but it doesn't. Okay, so now I'm going to draw a diameter, right? So I'm going to draw a diameter, and a diameter goes through the circle, right? Here, hopefully. There we go. And label that diameter. I'm just going to put a D because this is not the best, but it's free. And I don't want to spend a whole lot of money. I don't need to. So I'm just putting a D, but you can write it out. This is diameter, right? Okay. Now this should have all been stuff you already know. Now we're going to cover some new vocabulary. So a chord has the endpoints on the circle, but does not go through the center. It can go through the center, but then it'd be a diameter, right? This here, like this is called a chord. I'm just going to use a marker and put it up on the board. So chord is spelled Chord for this type of chord. So now this is a chord. You have endpoints on the circle. So this one's diameter. This is radius. Chord is a chord. Now, so this one you would write Chord. This one we write diameter. This one's radius. There's going to be two more you're going to draw. We're going to do what's called a tangent. You all say that word? Tangent. Now, what's weird is we use tangent when we use sine, cosine, tangent. This is a different, it's kind of the same, but it's different. When you get to calculus, you'll learn why it's considered the same. But for a, I'm going to just do this. I'm going to put a dot right there. And I'm going to kind of, there is a way to construct it, but it's going to take a little longer. We're just going to eyeball it. So a tangent just touches the circle at one place on the circle. It doesn't go through the circle. It just touches the circle at one spot. So I'm going to try and do my best. I kind of drew, right? I think that would go just through that spot there. Okay, yes. So, and what would I call this one? What's the word again? Tangent. And a tangent just touches the circle at one place. Now, if it's touching a radius, what's interesting is that this will make a right angle if you did it correctly. So this is tangent. If it touches a radius, this will always make a right angle. If the point of tangency, meaning the point where it touches the circle, here, this will make a right angle. Okay, and I got one more for us to have for your notes, and then I'm going to hand out the regular notes, which we'll still go over this stuff, but I always think a nice preview ahead is nice. So now we are going to draw what's called a secant. Can everybody say the word secant? Secant. So, and the secant can be drawn anywhere. All a secant does is it passes through the circle at 2 points. So, like this. See here how I pass through 2 points? I have a point here, and I have a point here. And what am I going to call this one? Secant. And a secant passes through the circle and intersects the circle at 2 places. So what's the difference between a secant and a chord? What's the difference? This one goes through the circle and on the other side. So it's out. You have parts of it outside the circle. Think about this being a line. Where a chord, the whole thing is in the circle, right? See the difference? Yes. What's the difference between a secant and a tangent? Tangent only touches the circle at one place. And it's outside the circle, right? Now a secant touches at 2 places. And I could draw a secant up like this, right? I mean, I could draw lots of different secants. I could draw lots of different tangents too. But if a tangent is drawn to a radius, that's when it's 90 degrees, okay? But only when it's a radius. Because I could draw another tangent, like I could draw another tangent here. You don't have to draw the, oh, not the tangent, that's going in there. Trying. This would not be 90 degrees, right? You can tell, is this 90 degrees here? No, it's only 90 degrees if the radius and the point of, this is a radius and this is a point of tangency. But we'll go over that a little bit more in a minute here. But I wanted you to have a pretty picture because pictures are worth 1,000 words, right? And it's always nice to have them in your notes. Plus, it's fun to draw circles. I think it's fun. You think it's fun to draw circles? Is it fun to draw circles? Maybe. Okay, so I'm going to go ahead. Okay. A chord is like a diameter, but it just does not go through the center. Both endpoints are on the edge of the circle, and it's going to be in your face. I just wanted you to have a visual before we started. Oh, I said make it big. It's easier to see. I have bad eyes. Oh, I need to erase my board real quick. Are they pretty full, or is we don't have? So students will learn the vocabulary of radius, chord, diameter, secant, tangent. Right? That what we did? We drew some of these. But then there's some theorems that go with all these that we're going to be covering. Okay, so here's the center of your circle, right? Center, the definition, if you're going to do a Pictionary dictionary, if I have center, it's all points are equidistant from the center of a circle. Right? It's the point that all these outer are equidistant. Okay? Did you get one of these? So, okay, radius. A segment whose endpoints on the center and any point on the circle, right? How many radii are in a circle? Is there only one radii? Only two? The infinite. That's right. So many. Think about spokes on a bike, right? If you have a bicycle and those spokes, those are all radii. There's actually infinite amount of radii in one circle, meaning many, 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 as many as you can draw, if not more. See? Radii, 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 all through there. See that? Okay. All radii in a circle are congruent. So if I say that this is 1 unit here, guess what? All of these are going to be the same 1 unit because all radii of a circle are congruent. So let's look at my example. If MZ is 4 units, right? Oops. I don't want to do that. If MZ is 4, which other ones are 4? MX, MW, MY. Is WX 4? Everybody say no. No. It would just be N, W, M, X, M, Y, and M. I can't see this. MZ, right? Any other questions on that one? Pretty easy so far. Label all the lengths that are 3 units long due to being a radius. Point A is the center of the circle. So I already know AB is 3. What else is 3? Just write it down on your paper really quick. I think I listed all on the next one. Oh, I didn't write it down. I thought I did. Oh no, I'm going to have to open this up in Cami because it's not opened in Cami. Okay, so what did we say here? Oh, that's 4. Oh, I think. So all of these would be 3, correct? A, B, A, D, A, E, and A, C. Any questions on that one? Because I'm going to erase it. There it goes. Watch somebody say, I needed that. Okay. Now, a chord is a segment whose endpoints are on the circle. So we see we have a chord. You drew a chord, did you not? Okay. Now, a diameter is a special chord. So we can call a diameter, but we could also call it a chord. But it's also the longest chord in a circle. It's going to be the longest one because it's going through the center of the circle. How many diameters are in a circle? But how many can we draw in a circle? Infinite. You can draw infinite amount of diameters. And all those diameters would have the same measure, right? So, I'm going to pretend that wasn't there. So let's look at these. Over here, what are all the diameters here? Can someone tell me one? A, B is a diameter. RS, XY, PQ. Did I get them all? 1, 2, 3, 4. 1, 2, 3, 4. Good. And all of those diameters would have the exact same measure, right? Okay. So, the center of a circle is point A. Don't go away, News. The diameters have a length of 10 units. Which segments are diameters and label their lengths? So look at that second one. The center of the circle is A. Oh boy, that's hard to read, isn't it? I made it super small. Let me go ahead and just clear this one out. Sorry about that. Yeah, it is too small. I have to fix those notes. You need a big magnifying glass. So sorry about that. So A is here. And you could draw this on the back. You all have the templates and stuff. If it's too small, we can draw it on the back. I'll give you a minute. since it's so small. So you can go ahead and draw this. Okay, so all the diameters have a length of 10. They want us to list the diameters. Here's the center. So what would be a length of 10? CB. So CB would equal 10 units. ED would equal 10 units. And is that it? That's it. There's only two diameters. Because here's the center. The only two diameters are going to be this one and this one, the ones that go through the center of the circle. So only those would be 10. Okay, secant. We labeled a secant earlier, did we not? And a secant passes through the circle and intersects the circle at 2 points. Now, tangent, a line in a plane of a circle that intersects the circle exactly 1 point. That point we call the point of tangency or point of intersection, but we call it the point of tangency. You'll hear me say that. Questions? And did you draw this? Did you draw something similar earlier? Yeah, we drew this earlier, so we don't have to draw this again. But it is in your notes. Okay, in the next one, again, that was too small. I have to fix this. I was trying to conserve on paper, but I failed because it's not really useful if you can't see it. So it's asking you to label each of these, pretending you didn't see the answers. Okay, from A to C. A is on the edge, and it's going to the center. So what would I call that? That's radius. DE. DE is right here, and that is called a tangent. AB. What could I call AB? Diameter. I could also call it one other thing. What else could I call it? Not a secant. Wait a minute. No, because AB didn't go through the circle. It's just the endpoints are here and here. Chord. It could be also called a chord. It's a special chord. It's the longest chord in a circle. What's AG called? AG is your secant. I'm gonna start erasing these so the next time it's done. I can't believe I can't just like not save. Oh, look at it. It's all nice and neat there. Okay, now let's look at the next one. Next one. What's the vegan. So the next one, use the diagram to find the given length. So each of these boxes are 1. So use the radius of circle A. How many units is the radius of circle A? 3. So I would just write 3. Diameter of A. So if the radius is 3, what's the length of the diameter? 6. You just double it. What's the radius of B? 2. So what's the diameter of B? Any questions on that? Oh, we good? It's my mascot. This one? Okay, the radius, 1, 2, 3, from the center to the edge. And if a radius is 3, you double it to get diameter. What's 3 plus 3? 6. Radius of B, 1, 2. So then what's the diameter? 4, because 2 plus 2 is 4. Got it now? Okay. Theorem. And we talked about this when we did our drawing at the beginning of class. In a plane, a line is tangent to a circle if and only if the tangent is perpendicular. I'm going to say that again. Perpendicular to a radius of the circle at its endpoints on the circle. So when we're talking about tangency, if I have a radius and it's drawn to the point of tangency, it makes a right angle because the definition of perpendicular is it makes a right angle. Questions? Concerns? Am I going too fast? Too slow? Just right? That's right? Okay. It's all right. That's what he said. Okay, so right here, I'm just going to rewrite it. To check to see if it is tangent, we want to check to see if it makes a right angle. For it to make a right angle, this would have to be a right triangle, which to prove if it's a right triangle, we can use and y'all thought you were done with this, the Pythagorean theorem. Because if this is right, then a squared plus b squared has to equal c squared. If it doesn't, tangency, meaning that it probably would intersect the circle again somewhere if it's extended, right? So the theorem states that if it is a point of tangency, it makes a right angle. To check, we can use Pythagorean theorem. So I'm going to see if this is a right angle by taking the two smaller sides and squaring them and setting it equal to the square of the larger side. If it works, I say it's tangent. If it doesn't work, I say not tangent. So over here, 12 squared plus 35 squared. Does that equal 37 squared? Here, Eileen, if you want to use this calculator. Okay. So 12 squared is what? 144 plus what's 35 squared? Okay, and then what's 37 squared? And I'm going to add these together. If this is a total of 1,369, then it is tangent. If not, we say not tangent. So I add 1,225 plus 144. I put minus on my calculator. That wasn't good. There we go. Yes, it is true. 1,369 equals 1,369. Check. It is tangent. Okay. So how do I do this one? This is R. Okay. Now it's saying find the length of R if it is tangent. So this would have to be a right angle because it says in the diagram, B is the point of tangency. Find the radius of R. So I'm going to do R squared plus 80 squared has to equal, what is this length here? No, 50 is just from here to here. Now you have to add R and 50 together. And I have to multiply this out, right? You're not going to just say R squared plus 2,500. We actually have to work this out. So I know this is R squared. What's 80 plus 8 or times 80? That'd be 6, 4 with 2 zeros, right? Okay, now I need to multiply this out. R plus 50 times R plus 50 equals R squared, because R times R is R squared. 50R plus 50R is 100R. Because when I take 50 times R and 50 times R, they're both 50Rs, and then you add them together. And then plus 50 times 50 is 2,500, like that, right? 25 and 2 zeros, yes. So down here, I'd write R squared plus 100R plus 2,500. Okay? Now, do you see how you have R squares on both sides? Those cancel. When you subtract R squared off of each side, these cancel. Here you go. There's a chair over there by Beth. So now I'm going to subtract 2,500 from both sides. And I get 100R is equal to what? What's 6,400 minus 2,500? 8,900? Oh, 3,900. See, I have bad ears. 3,900? Everybody agree? Okay, divide by 100. What would R equal? R would equal 39. And I think oh, it didn't quite keep it nice and neat, but there's the steps, right? Yeah, those were the steps we did. Okay, so you try to do this next one on your own, and I will walk around and check your work. Hey, Eileen, I have to cover at lunch the so for number one, If from here to here is 2, then from here to here is 3 because this is also a radius. So this length is 5. So does 3 squared plus 4 squared equal 5 squared? 9 plus 16 does equal 25. So then we would say, yes, this is tangent. And we know this because of the Pythagorean theorem. For this one, who got the answer? I know Chit Chit did. Did anybody else get an answer for this one yet? Are you still working on it? You're done? You got an answer? What'd you get for your answer, Lean? 7? Is that what I got for mine? It is 7. I had my piece of paper. Oh, there it is. Yes, 7 is the correct answer. Yay! Did you get 7? Okay, make sure everybody in at your table also gets 7. So if someone else hasn't gotten it yet, make sure they get it. Okay. So, because we had a little one who needed to go to the restroom, I'm going to do this one. So, if it's saying it's tangent. So, if it's tangent, that means this is a right angle, which means you can use the Pythagorean theorem. A squared plus B squared is equal to C squared. A would be R, so R squared. B would be 24. 24 squared has to equal this whole length. Well, what is this whole length? R plus 18, and I have to square it. So this would be R squared plus, what is 24 squared? 24 squared, 576. And this one you have to do R plus 18 times R plus 18. R times R is R squared plus 18R. And then you get another 18R. And then you have to multiply 18 times 18, which was what? 3, 2, 4. When I add the 18 r's together, I get, well, this is r squared plus 36r plus 324. These r squareds cancel out. So now it's just a two-step equation. You subtract 324 from both sides. When I subtract that, what do I get? 252 has to equal 36r. You divide by 36, and r is equal to 7. This one stated, well, these two have to be equal. X squared has to equal 9. When you take the square root of both sides, you would get a plus minus 3. However, can I have a negative side length? No. So in geometry, we throw out that negative because you can't have negative side lengths, and the answer is just a positive 3. We got it? Okay. Feel good? I hope. So now we're going to do a couple more theorems, and then I'll give you a break and a chance to do independent practice. But independent practice first, then break. Okay, if one chord is perpendicular bisector of another chord, then the first chord is a diameter. So it turns out, and we're going to use that for those who choose the projects. So for those who choose the projects, I can find my bag of my bag of partial lids. But anyway, I take lids, I cut them. You have an outer curve, and archaeologists actually use this for when they are doing archaeology digs. And if they find like a platter or a plate and they want to find the full original circle, they use this type of geometry. They use the idea that if I have a chord and I do a perpendicular bisector and pass it through, that's going to give me the center of the circle. If I do two chords, it's going to be where they intersect, which I walk you through all the steps on how to do it. Um, okay, so if one diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So I think this is the first time we talked about arcs. Arcs is part of the outside of your circle. So see here how we have like AB is an arc. Well, if this is the diameter, it cuts this chord in half and it cuts that large arc in half. So AC's measure is going to be equal to CB also. Okay? Let's see how we apply this. So it's asking, use the diameter E to find the length of AC. Well, if this is the diameter, which it is because BD goes through the center E, and I see that this makes a right angle, then these two pieces have to be equal. So if AF is 7, what's FC? 7. And I want to know the length of AC. Well, if from here to here is AC and this piece is 7 and this piece is 7, what's 7 plus 7? 14. So AC is equal to 14. Ooh, someone's saying over there. Now we're looking at the chords, right? So it says find the measure of the indicated arc in the diagram, and then we're going to find, so we're going to have to find x first, and then we substitute in to find the actual measures, correct? If this is the diameter and this is the chord and it is perpendicular, it cuts these two arcs in half. So each of these arcs are what? Equal, right? So I would do 9x is equal to 80 minus x. And then I add x to both sides. I get 10x is equal to 80. I divide by 10 on both sides. What does x equal? X is equal to 8. Now, to find CD's measure, arc CD is equal to 9 times x, but what's x? 8. So what is 9 times 8? 72. And they're talking about the degrees. So I think, so remember that a circle, oh, can I borrow this? You only have the half circles. This is the full circle. How many degrees is a full circle? 360. CD is part of the arc of the circle, and it is part of it, and it's 72 degrees. So then what would DE have to be? It's the same. So what would I write? Just 72 degrees. I don't have to do any extra math. These two have to be equal. So then what's the whole arc of CE? From C to E, what's 72 plus 72? 144 degrees, because I took 72 degrees plus 72 degrees, and that equaled 144 degrees. Yay or nay? Yay. Okay. Ooh, that one is small. Look how small this one is. I can hardly see it. Uh, in the same circle, two chords are congruent only, if and only if, sorry, they are equidistant from the center. Is this one not on there? I don't know why that one's not on there. That one's weird. Okay, on the back, if you have extra room, go ahead and do this one. Sorry. So if both of these are coming off the center of the circle, and this chord is 16, and this chord is 16, the length, the distance from the center has to be the same. And I agree, it is very small, so I'm going to make it bigger. Please draw this on the back because it's not on your paper. I don't know why. I'm going to have to fix these notes. That doesn't help you, but I'll help the next class. And I think I said that last term, and I still didn't get around fixing it. But I got to write a note to myself. Maybe somebody could write a note on the board. Fix the notes. Okay. Can you see it better now? So use your little template, draw a circle. Because these chords are of equidistance, see how QR is 16 and ST is 16? I mean, not equal. These two chords are equal. The distance from the center has to be exactly the same because it's a circle. And so if these two are equal, the distance from the center has to be also equal. So you would just say 2x is equal to 5x minus 9, and then you would solve. And then if I wanted to find the distance, I substitute back in. So the distance from the center for each of those chords is 6 units. I just got to get some more stuff straightened out outside. No, you're not the only one. There's like 3 of them. Yeah, I know. I know. That's good. Hey. Okay, so right here on the back, they didn't have one of these as an example. So let's look at number 9. It says to find perimeter. What does perimeter mean? What does perimeter mean? All the way around the outside. So you have to add each of these pieces together. The problem is I do not have all the pieces, right? However, I did tell you in a theorem that we had that from here to here, if all of these lines are tangent, has to be the same as from here to here. So if this is 5.7, what am I going to write right here? 5.7. And then what about this side? 15.5, right? Now I just add all of these numbers together to find the perimeter. So just add all of those with your calculator and you'll be able to find your perimeter. Some of them get a little trickier. I just read an article on how students should struggle a little bit because they remember things. So before going over it, I'm going to let you guys try and figure out those yourselves. I'll give you more on the do now tomorrow and see if, let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So what'd you all get when you added them all together? What'd you get? That's why I circled them all. Yep. 66.9. That's what I got. And you have the answer on the back, right? Which one? What number was that one? 9. Oh, what happened? Oh, what happened? I just said the struggle, and I, okay. So let me talk about why that was not correct. Turns out there was an overlap here, right? So I need to figure out what this little overlap is so that I can figure out what this length is. So I'll figure out what this length is, right? I'm going to change the color for a minute. So I need to do what? I'm going to need to walk around, and if I know that from here to here is 10, then from here to here is 10, how am I going to find this distance from here to here then? Yes, because this is 10, this would have to be what? 4.5. And so if from here to here is 4.5, what's from here to here? 4.5. So then how do I find this length? Subtract. So this would be 11, which would make this not 15.5, but 11. So this would be 11, 5.7, 5.7, 10. Be careful. Sometimes students end up adding these ones that I put on the inside. That's why I put some on the inside and keep some on the outside. And I only add the outside ones because I don't want to add more than what I'm supposed to. So then 14.5, 15.5. Now let's try adding those together and see if we get the correct answer. Do we have the right answer now? Did you get 62.4? So be careful. You may have to do that. Walk around and find missing pieces. It's like a puzzle. And you have 2 to practice on. Okay, so take a minute at the board for dates. So I lost a day yesterday due to that meeting, right? And then gave you some extra time to decide whether or not you wanted to do the projects or if you want to do final exam. And I gave you the final exam review and I gave you the projects. Some of you are choosing projects, some of you are choosing final exam. Monday, then, normally we have our tests on Thursday, but I lost a day. So, Monday at the beginning of class, we will have a test over circles. I will give you a review on Thursday. If we have time, we'll go over it. If we don't have time, you'll have to go over it yourselves. I may post a video of me walking through all of them for you so that way you would be able to see that because I lost that day. There's just not a whole lot I can do on that one. And then after that test, which I'm going to make short, I'm not because I am going to have to make it really short so that way it only takes half the period, hopefully less than half, and give you more time to work on your projects or study for your final exam. Those who are choosing final exams, if you want to take it on Monday, that's fine with me. You could take it on Monday or Tuesday. Wednesday, we're doing presentations for the projects. Depending on the presentation of the Pictionary dictionary, you may be able to take it the second half, like of the class, depending how many people are presenting. Thursday morning, I will not be here. But if you are still working on projects Thursday afternoon, my other classes should be done with theirs. You can also visit me and either take the test. But Thursday's the last day. So all late work, all missing tests, everything needs to be done by Thursday. Does that make sense? Wednesday are presentations for Pictionary Dictionary. Now, if you were not here yesterday, I do have the information all printed out. You have two mini projects. One is to create a Pictionary dictionary so you'll do vocab and a picture that is themed. I'll show you during break. I can show you what it looks like. And then you have a construction with compasses that I walk you through it. You make regular polygons. So you're going to make a equilateral triangle, a square, a hexagon, and is that it? And then you have the lid part of the project. I think there's a bonus on there if you want to try the pentagon because that one's trickier. Any other questions about final exams and stuff? So I gave you the practice. Again, I lost time. So I'm going to give you a break. I will have more. I'll give you probably an extra 15 minutes when you come back to look over those problems on the packet. And then I'll have to give you the notes for central and inscribed angles. Okay? So you can work for a little bit longer. You can take a break if you need to. At quarter till, I will start going over the central angle notes. Okay? Makes sense? Sorry about that. That was totally out of my control with that meeting. And